Why is this one? This one is easier than the last one. 100%. Okay. Well, I used you didn't put it aside, but I used the you said that was I got one more at 5 minutes. Well, when I turned it in, I saw I don't know how some that I'm the person that came in but what did that you do? Plus the lab or so. No, we have to take a experience test. I was 79. So basically, you know how to that's a spear scrap piece of paper. Yeah. So basically, you going to rip out this one piece of paper. Now, it's worth a shot. No. Did she give you? I think she does. She makes you flip them over and check. That's good. You get that. You get a 0. What if you just try to X? I won't do that. I'm going to study. I need to. I'm just going to get some carrots. I kind of know, but I don't really know. But the hub, whatever, and I need to study the hub. No, the hard. Yeah. It's real. Paracino, K, all of the hot air, all of the vocab. The sentences were all of the vocab. It was like toy store. I know. Cut the grass. Yeah. Make sure, I don't know. I don't know how to do the probably like. There's like he probably had fun. It was like you had to use the conditional. Make sure you know all of the hot air. Like I had a bunch of paper and I wrote down all of the kinds of things. She gave you a piece of paper? No, I had a fact sheet and I showed her. I need to test her. I wrote because you have to know present, future, past, future. Like all the last time. Yeah. And then you have to know all the past parts. The past parts. No, they can keep face. He doesn't have to try. Right. Make things. You didn't even have to try. But you remember this? I studied for like 2.5 hours. Dude, I studied all of them. I studied for 2 hours and I'd be happy to give them up. Dude, I studied hard though. Yes. Yeah. Well, no, just know. I could literally. I told you, remember? I said, do the math and see what I did in this class if I got a 0% on it. And she did it, and I would have gotten 80. So these things I just do that. No, in this quarter. I would still have an A in the semester. Except the last because you can pull it off. But if I get a B in the quarter, and I don't have 3 exams. I'm 79. Yeah. Okay, so for my chemistry exam, so he's giving us the exam ahead of time, and we have to do it even if we're not. Hopefully it doesn't break me down. So I have to 79. What? Yeah, I don't want that. You don't bring it down.
Study package or.
But that's too, I'm in French. They don't probably bring me down. I hope it only brings me down. If it brings me down, and then we still have the two. Evan doesn't have to assign. What? Evan doesn't. He doesn't. What is it? No, you need to have your eyes.
Anyways, this is like a first study.
I studied for literally 2 hours. I studied for an hour this morning. Like I woke up at 5. Just the pause, you know. Yeah, I know. No, I'm memorizing. It's like great. 15 pages. I You did? Why? I don't even I just studied for 3 hours. Why are you wearing everything? Which ones did you do?
I thought that was supposed to be red, but I didn't see it here.
I did.
Oh,
This is easy.
she's like, all right.
Just to.
Yeah, I didn't even.
I actually, I did this test in high school.
You don't watch them. Watch action. No, I didn't.
It took us 30 minutes.
And then this one,
Hello. Woo! All right. Well, we are ready to go today. Hopefully, you went online and found the problems last night, and you'll be ready to go over those. Okay, so let me. We are missing. So it looks like we're missing Owen. I wonder if he's not doing that. I don't know. Get rid of that. Okay.
What, you're gonna get like 100.
That's good. That's good.
I even talked to her after.
Okay, so you guys, yesterday, let's go ahead and get busy here, guys. So yesterday we went over rational functions and we were talking about how to find both horizontal and vertical asymptotes. We also mentioned how to find zeros, what those would be if you wanted to find those. So I posted yesterday online, when I posted the notes, I also posted practice problems for you. Those practice problems were these problems right here. Okay, so we're going to go over these in a second. Now, when you did these, you were able to do domain, zeros, vertical asymptote, and horizontal asymptotes. The only thing here you could not do would be the holes, because we haven't talked about that yet today. And we will talk about that today, right? So what I want to do real quick is a quick little like review before we do that. Yesterday was rational functions. So rational functions, f of x is equal to p of x over q of x. And p of x and q of x are both polynomials. What was true about the bottom one? It had to be what type of polynomial? First degree or more. So it has to be linear, quadratic, cubic. It can't be a constant term, in other words. Okay? The top, though, can be a constant. It can be a linear, quadratic. It's any type of polynomial on the top. Okay? So let me ask you this. Zeros. How do you find the zeros? What on the rational function gives me the zeros? Yeah, you set the top, p of x equal to 0. Okay? So you find the zeros of the numerator. That's the zeros of the whole thing. Then the next part was the let's go ahead and do the vertical asymptotes next. What determined the vertical asymptotes? What did we use? Yeah, the bottom was equal to, so you're finding the zeros of the denominator now. Okay, what makes the bottom undefined? The other part of this was the horizontal asymptotes. What did we use for the horizontal asymptotes? What about P over Q? We had to use the degrees, okay? So this is where up here, let's say this has a degree of M, and let's say the bottom has a degree of N. There were three scenarios. You could have M equal to N, you could have M less than N, or you could have M greater than N. And each one of those gave us a certain asymptote situation. This is what I asked you to memorize. What happens if they're the same? It's the top leading coefficient, so it's the top LC over the bottom LC. LC stands for leading coefficient. Okay, and it's a y equals that. What if M is less than N? This is the y equals 0. It's the x-axis. And the last one, if M is greater than N, that's when there's no horizontal asymptote. Okay? So you have to know those things. How do you find zeros? Set the numerator equal to 0. How do you find vertical asymptotes? Set the denominator equal to 0. And how do you know horizontals? It's all about the degree of top compared to the degree of the bottom. And knowing these three rules. Memorization of those. All right. Now, yesterday, we kind of flew through at the end. This was one of them that we did yesterday in class, kind of at the very end. Okay. So I said this had no horizontal asymptotes. Why is that? Because the top is greater than the bottom. Okay. Then I said it had a vertical asymptote at x equals -4. Where does that come from? I said, yeah, we said, oh, x plus 4 equals 0, and we solved it, we get this. Now the zeros would be from the what? The numerator, right? So I would set this equal to 0 and solve it as well, okay? So I'd go x squared minus 16 equals 0. So x squared equals 16, right? So x would be equal to positive and -4. Now, does anybody notice anything right now? Does anything just like on the screen make you go, wait a second? Wait, Brady, I'm sorry, yes. The vertical asymptote's the same as one of the zeros, okay? So what I want to do is I'm going to go to our Desmos. I'm going to go to a graph here. I want to look at this one in particular. So let me pull this over here, and I'm going to type in my original function. So it's h of x equals x squared minus 16. And then that is being divided by x plus 4. Now we're going to go ahead and look at this. Okay. Now, when I look at it, the first thing I notice, there is no horizontal asymptote. That's good because a horizontal. What does the graph do if there's a horizontal asymptote? It kind of flattens out as it goes to the left and the right. It almost becomes horizontal. Okay. The vertical asymptote, though, should be at x equals -4. I'm going to graph that. X equals -4. It's saying there should be a vertical asymptote there, but there's not. What does it look like the graph's doing? It doesn't look like it's just going straight through it. I mean, if I zoom in there, look at it. So you know what I'm going to do here? I want to type in h of -4. And look what it says. What's it say? Undefined. Why is it saying it's undefined? There's no asymptote there. There's where a hole is. Now, how am I going to know when there's a hole in the graph? Well, when the numerator and denominator have a common 0, there's going to be a hole at that location. That's why there's a hole here. Since x equals -4 shows up here, and x equals -4 shows up down here. Since these are the same, that means there's a hole at x equals -4. Okay? Yes?
Would x equal -4 no longer be 0?
It would no longer be a 0, and it would no longer be a vertical asymptote. It would be now considered a hole. So this would have no horizontal asymptote, no vertical asymptote, a hole at x equals -4, and a 0 at x equals +4.
Would it not have the same thing?
No, because the +4 was not a vertical asymptote also. Okay, now we're going to look at those more today to make sure we understand that. Okay, so that's what was going on when we didn't get to it yesterday, the holes. Now, let's look at the homework. So here's the homework. So let's see if we, that's good. Okay. So on the very first one here, it asks for the domain. Now, the order I put these in, I just typed them as I was thinking of them. Maybe you want to find these in any order you want. What of all of these, what's probably the easiest one to find? Like of these things here, which one's really the easiest one to find? The horizontal, because there's absolutely no computation really involved. So let's do the horizontal first. We'll do that here, and then when we get to this one, we'll do the same thing. So the horizontal on this one, we're going to start right here. So degrees are the same. So I use the leading coefficient. So it's 2/1. So it is 2. So this would be y equals 2. Got it. Okay. Now, let's go ahead and do the, I don't know, vertical asymptotes next. If I want to do the vertical asymptotes, VA, we said that's where I do what? Set the denominator equal to 0. So I'm going to make it x squared minus 2x minus 15 equals 0. Okay, does this factor? X squared is xx. I need a -15 product and a sum of -2. -5 plus 3. So right now, it would look like there should be a vertical asymptote at x equals 5. And looks like there should be a vertical asymptote at x equals -3. Okay, that's what it looks like right now. I'm going to write them down. X equals 5. X equals -3. Now I'm going to find the zeros of the numerator. Now, when I do that, if I see a 0 show up here that's the same as here, I now have found a what? A hole. Okay? So let's do the zeros. So for the zeros, I have to set the numerator equal to 0 and solve it. All right. Let me make this stuff here a little bit smaller. I'm going to actually just move it up here, kind of over. Okay, perfect. Here we go. So now 2x squared plus 12x minus 32 equals 0. What should I do first? Pull out the greatest common factor of what? 2. So now I have 2 times x squared plus 6x minus 16 equals 0. 2 times, okay, here we go. X squared, xx, -16 product, sum of 6. What is it? 8 and -2. So plus 8 minus 2. So here's x squared. There's my minus 16. 8 and -2 is positive 6. So what do I get here? This is going to give me my 0 at x equals -8 and at x equals 2. Are any of them the same? Are any of these the same as these? No, they're not, are they? -8 and 2, 5 and -3. So what's that tell me? There are no holes. There are no holes on this one. Okay, now the domain. The domain is the what? X values. So what X values am I not allowed to use? -3 and 5. So my domain is -∞ to -3, stop. -3 to 5, stop. 5 to infinity. Remember doing that way back when? The intervals. Okay, there's 2 breaks in the interval. That's why I end up with 3 pieces to it. Questions on number 1? Yeah. What do you mean? Looks like it goes through the horizontal.
Well, it looks like there's like 3 lines.
Let me go ahead and do it. Let me grab it for you. Okay, let's talk about this. Let me go ahead and put it in here real fast. Where's it at? So we've got, come on, cursor. I think my computer is ready for summer break too. Okay, 2x squared plus 12x minus 32, and the bottom x squared minus 2x. X, come on, not, geez. And minus 15. Okay. All right. Now, so we said, where did we say the horizontal asymptotes were? Was that, I should say, y equals what? Okay, now, remember what I said a horizontal asymptote was. I said it's what the graph approaches as you go to the left and the right. It can cross over the horizontal asymptote at some point in here. That's okay. But as it goes to infinity and negative infinity, it will get closer and closer to it. That's the definition of a horizontal asymptote. So it might cross over it somewhere in here. Okay, it might cross over it somewhere in there. Okay, that was a good question because we didn't have one like that yesterday. Anybody else want to say anything about number 1? Okay, number 2. Let's do it the same way. Let's start with finding the what? Horizontal asymptote. Degrees are the same. So it's leading coefficient. So it's 1 over 1. So it is 1. So the y equals 1 is the horizontal asymptote. All right. Let's go ahead and do the vertical asymptotes next. So that's the bottom now. So x cubed minus 8. Okay, there it is, x cubed minus 8. Set it equal to 0. So what? X cubed equals 8. So what does x equal? 2, right? Positive, that's the cube root of 8, 2. Okay? So what's it look like there could be? Looks like there's a vertical asymptote at x equals 2. Now we're going to go ahead and do the zeros. So now I take x cubed minus 4x and set that equal to 0. First step, GCF. What can I factor out of this? S. So x times x squared minus 4 equals 0. So that's x times, this is the difference of 2 squares. So that's x plus 2 and x minus 2. So it looks like my zeros are x equals 0, x equals -2, x equals 2. What do we notice? Yep, there's going to be a hole. Where? At x equals 2. So if I'm going to write these down, because this is the way you could approach it tomorrow if you wanted to. And as soon as you see this, you say, x equals 2. Right? Yeah. The vertical will be a none. And if you wrote this and just crossed it off and left it like that, I would know that the answer was none. You don't have to write it. Now, if you left it completely blank and never showed me x equals 2 here, then I'm not going to give you that. There better be something there that lets me know you understood it. So now I can do the domain. The only restriction on the domain is x is not allowed to be equal to 2. So my domain is negative infinity to 2 and 2 to positive infinity. All right? The big thing here is you got to memorize these new rules and you have to be able to factor still. All right? Any questions on this one? Okay, here we go. Number 3. Let's again do the same thing. Horizontal asymptote. Degree is top heavy. It's bigger on the top. None. So this is a none. Okay. Let's take care of vertical next. Here we go. So the vertical asymptote would be x cubed plus 2x squared minus 3x equals 0. Factor out an x. Factor x. Does this factor x squared plus 2x minus 3? X minus 1, x plus 3. Okay? So looks like my vertical asymptotes are at x equals 0, x equals 1, x equals negative 3. I'm going to write them down there. X equals 0, x equals negative 1, x equals 3. That's what I just, oh, sorry, positive 1 and 3. Backwards. X equals negative 3 and x equals 1. I'll try that. All right, let's do the zeros next. X to the 4th minus 81 equals 0. That's the difference of two squares. What does it factor as? X squared plus 9 and x squared minus 9. Now this one does not factor. The sum of two squares does not factor. And if I tried to solve it, this would give me x squared plus 9 equals 0, so x squared equals negative 9. Does that have any real solutions? Yes or no? No. So do I have to worry about it? No. So I can stop with this, so I don't have to worry about it. Over here, x squared minus 9 equals 0. That means x squared equals 9. That means x equals positive negative. X equals 3. X equals negative 3. Woo, woo. What do we notice? Cancel, cancel. Where's it go? It's a hole. Now I got to finish up the domain. Yeah, Brian.
So for the x minus 81, I did.
Whoa, the x, you mean the x to the 4th? Yes.
So I did x to the 4th equals 81, and then I just went straight to x plus 3x.
Well, if you do this, you can do that. X to the 4th equals 81, then you get x squared equals positive or negative 9. Take the square root of both sides.
I just knew that.
You can do it that way. That's fine. I'm not saying you have to do it a set way. I'm just going to it one way so people can visually see it. Okay. So now the domain, how many restrictions are there on the domain? How many x values are no good? 3. There's 2 here and 1 here. So I have to write my domain now. So I go negative infinity. What's my first break? Negative 3. Then I go from negative 3 to what? To 0. And then I go from 0 to 1. And then I go from 1 to infinity. How are we doing on this? There's memorization and factoring involved, guys. Okay? And yeah.
I had a question. It was just something I noticed when I asymptote at like y equals x for that one? Because if you take
This one here,
over the bottom, you get like a y equals x, and that like whole line never.
yeah, if you took this and did long division on it, your quotient is the linear function that is the slant asymptote.
Okay.
We're not going to worry about slant asymptotes in here, but that's how you do it. And if it was quadratic, if the difference was 2, you would get a quadratic and you'd have a double slant asymptote. So it's all about long division that we did way back when that you don't like. Okay, that's where that can come into play to find asymptotes. All right, let me go ahead and let's try a couple here. So for all of these guys, let's go ahead and put down the order we're going to do these in. So the order that we like to do these in, and when I make up the test, I'll rearrange them. What do we want to find first? Horizontal. So we're going to find the horizontal asymptote first. Then we found what? Vertical. Then we found, now if after these, what could you find? You can find the zeros. That's good. Somebody said it already. What should I put next, you think? Holes. Because these two right here give me my holes. And then last is the domain. So I'm just going to put a problem up here, and I would like for you to find those 5 things for it. That's it. Just like we've done. Because really the only thing new we've done so far is we've included now this new thing called a hole. All right? So let's try this one. Here we go. Yeah. Try that one start. And I can tell you right now, on Thursday's test, the first page, there's only 2 pages front and back. The first 3 problems are just like the homework you did. Same style. You're going to get to practice one of those for tonight as well. Okay? And the goal is, I'm going to try it now. The goal is on Thursday, I want to be able to grade that second period we're together. I'd like to take it first period, second period, grade it so you know your grade before you leave. That's the goal right now. I'd love to be able to do that for you. Okay? We have it? Yes. All right. Horizontal asymptote y equals 1. Okay. Vertical asymptote set to what equal to 0? Denominator. Is that right?
No.
Minus, minus. Just had to go ahead and see if you're paying attention here today. So that means x equals 6 and x equals 2. Now, x squared plus 3x minus 10 equals 0. That's x plus 5 minus 2.
Yes.
So x equals negative 5, x equals 2. That's a whole. Okay, so now I know that. Cross those out. So now my domain has how many restrictions? 3, right? One vertical. Does it have 3 or 2? Why does it have 3? Doesn't it just have 2? This one and this, the holes in the vertical asymptotes, those determine the domain. Those are the values of x you can't use. So this is going to be negative infinity to 2, and then 2 to 6, and then 6 to infinity. You good with that? Questions on that one? Were you using the 0 as well?
Yes.
Remember this. Yeah, once we've done this, the 0 has nothing to do with the domain. Okay, in the end. All right. So we're going to do the exact same thing. I got 2 more practice like this before we do our last topic on this. Okay. So again, we're doing those exact same things. I'll write those down in a second. Let me give you the function to start with. Of course. I'll have them in today. I'll have them in today. I have nothing planned after school today, fortunately. Read this. I know everybody has the first part, always. This is. What are my factors for the bottom? 1 and 6? -6 and +1. Yeah, okay. So that means my zeros for the bottom are x equals 0, x equals 6, x equals -1. Okay, numerator now. We're going to get x times x minus 2, 8. -4 plus 2?
Yeah.
-4 plus 2, so x equals 0, x equals 4, x equals -2. Talk to me.
No.
There's a hole where? At 0. Okay, so now the restrictions, there are 1, 2, 3 restrictions on the domain. So my domain is -infinity to -1, -1 to 0, 0 to 6, and then 6 to infinity. How are we feeling? Are we feeling like we're going to be good on this? I can tell you right now, in the past couple of years, I've always done this at the end of the year, and I do it because I think it could be your best test grade to end the year with. If you're willing to memorize the basic rules, the new rules we've been learning, and you can still factor. And I'm giving you things that, if you notice, I haven't given you any crazy factorings. I haven't given you like 8x squared, where I'm not doing that to you. That's not the point of this. So you all have the ability to end up with a really good test score on Thursday. Okay? All right, so I'm going to put the last, yes, Krista. Yeah, I can tell right now, there's, like I just said, there's 3 like this on the front. And then on the back is the stuff we have to talk about after we've done our last practice problem here. Say that again.
Will there be any that won't factor?
On the test? I don't think I have any like that. No. No, I don't think I've done anything where you have quadratic formula that you have to use. Correct. Okay. All right. So we got one more like this we're going to do, and this will take us into the next period. And then when we come back, we'll go over this one. Last one, let's see what I write down here. That's the last one.
Yes. You know, I'm still not remember. I don't understand. It's just the center. Where the numerator is bigger.
I'm not sure.
Who's paying $6? That's it.
I don't know, but
I got this third topic.
I think you
You don't have to memorize the number.
Yeah, honestly, I know the present tense and the conditions. A plus,
I'm in the States.
no, hemos, so, yeah, bro, this is definitely not gonna be good.
This isn't factor.
Okay.
Yes, it'll say he will have or he has. Yes. Do the Quizlet for the past part. It's just the past part.
Oh, I didn't see it. I didn't read it.
49 past part. This is all, I don't, it's so easy.
So wait, you just had it, I know.
No, don't do the past part.
There's a bunch of you.
Put the passports after the hopper. Right? Okay. I just need to remember.
Yeah, I know, I've sent it to you.
We also had a chemistry test today.
Nice.
Okay, do that. And then that's your passport.
So then is it?
And you get on, no, like save your problem.
No, I didn't have to do this. You just add, you put hot air and then these.
What's the?
Yes.
Remember that? Yeah. Sam. Sam, go to control F. Look up the people. Okay.
I don't know that I
D-I-C-K. But yeah, still, no, don't, I don't even look at that.
So let's say.
Oh my gosh.
Just put it in green.
Like 8.
Oh, wait, I got a 70. Oh, I got it in.
On what?
No, on my headset.
Oh,
But I sent it to Ev. Yeah.
Well, I haven't changed everything.
Yeah, and I guess I got like a 71 out of 74. So,
Bro, really?
yeah.
70. Did you actually?
Yeah,
That's sweet, guy.
I don't know how he graded it actually.
Evan said it sucked.
Because he's.
Yeah, you just got an A on it.
I don't know how Archie graded it. Probably not that hard.
It was like curvy. Yeah, 11%. What did you get?
A 71. Bro, that was.
Hey, bro, I got
A 69? Honestly, that's better.
No, 69 out of 74.
Yeah, I got it.
Dude, this country.
I said it's slavery.
Dude, English is so. Dude, our
Oh my
English
God,
teacher is the best.
I think she's on me.
She's the best teacher, dude.
I think she's.
It doesn't matter, dude.
I think she does.
Oh my god.
Alright, when's our next quiz? Thursday? Over the entire book?
You didn't know.
How many chapters?
She said use your timeline. She said the timeline.
No.
There's 100. I have like 27 chapters.
I can't get up there.
I'm only on 77.
I'm in 101.
That's really hard. What am I doing?
Why are the speakers like this? Alright, we're gonna skip Spanish today. Take the test.
It's just game so. Dude, I'll be happy with this.
I don't even know. How much percent could it possibly be? No, he said it was like 14%.
Yeah, you only go down 14.
So 7%.
If you get a zero,
So what is like a C?
depends on what your grade is.
I would 92.
I had a 96, which put me down to 14% to go down to 7.
15%.
Well, it's 'cause-
I was 79.
Wait, I just thought about that. That's literally like the percentage of an exam you're around for.
Yeah, she basically gave us the exam before we actually.
I mean, but she's done those tests throughout the year, so it's not like it's not like Senora Hades where it was just like literally 300.
Did she really?
No, it was literally like 400. What was? Yeah, Senora Hades 4 exam tests. What was that? I don't even know.
Didn't the exam you have to learn Spanish things?
It was literally like 400 points because she made it. Because each quarter she got over 1,000 points.
How hard is it?
It was so annoying. And literally, Sam, it was Sam. She gave him like 40 points of extra credit, and he still had a B. So that she rounded up after he had 40 points of extra credit. You remember that, Sam?
Yeah, I should just ask.
He had like an 87 and she rounded it up.
I earned those. I went to the. Literally like movies after school.
You had to. Everybody was forced to. Which is not. I don't even think you can't do that.
You should say, you can please get a B.
She literally.
Yeah, she'd go to
Yeah. You'd have to stay after school. Like, your hours. Yeah, like.
That's why you go to Spanish.
I just made the regular one after school.
You get a C.
No, it was for after.
I've seen it.
And you know how she'd get away with it? She would be like, okay,
You did
so
too.
you can either do this
Did you?
for Spanish school for 2 hours, or you can do this ginormous project where you literally, I'm gonna give you an F on it. Like, pick your board.
Oh, you weren't. My bad. Never mind. I forgot.
We did. In school, we didn't do any notebooks. It was all online. All our notebooks. And we had pens and stuff. We could write on our screens.
We didn't talk about
Last year, we only used our computers such as our notebooks.
Sucky wrote.
It was called, what was this thing called? Notebook. It would be like this on. Yeah, because you could
Oh,
save.
no.
Right? You could like.
This one's like.
Yeah. I mean, you had a pen, so you could actually like write in. Some classes.
I got all these.
Most of you stayed in here working on this, I'm sure. Okay. Well, I'll just, so horizontal. Y equals 0, right? Because it's got a bigger degree on the bottom. So this is one of those. Okay, so vertical. Those are going to go over here, so x equals 0. Okay, 2x squared. Now this is the first one I've kind of given you where you don't have a GCF and it's not a 1 in front, but I made it a prime in the front and a prime in the back. So for factoring purposes, this would be an easier one. So 2x, x, 5, 1, plus, plus. So it looks like x equals negative 1/2 and x equals negative 5. And sure enough, we notice that there is a hole at x equals negative 5. So now I can write the domain. How many restrictions? 3. Here we go. It looks like it's negative infinity to negative 5. Negative 5 to 0. 0 to 1. And 1 to infinity. What do you think? Yes? Any questions on any of this? No? All right. So I'm going to actually put this graph up on the board for a second. I'm going to go ahead and graph this because I'm going to use this to go into the next lesson. Okay. So let me go ahead and graph this. So I can just modify this. Plus 11x plus 5. And the bottom, x cubed. Okay. Oh, get rid of this 5. Boom. Check that funky graph out. Okay. So I'm going to cut that out. Oh, let me get rid of that y equals. What was our horizontal in this one? Y equals 0. And I'm going to put all of my things in here. So y equals 0. And then my vertical was at x equals 0 and x equals 1. Is that right? Okay. Let's make those a different color. Let's make those both orange. Yeah, orange is fine. Actually, let's not. Let's make them green. Okay, so here we go. Now we can kind of see all this stuff going on here. Okay, so let me cut this. I'm going to look at it. Here, close this off. Page. Okay. Now, what I'm going to write down up here is the last thing we're going to do is the thing called limits. Okay. So what first is, what is this notation going to look like? So you're going to start seeing me write down this. Okay, here's what you're going to see. And then there's going to be something here, and there's going to be nothing here. This is where your answer is going to go. Something's going to go here as well, though. Okay? Now, the things that are going to go here are, it's telling you, hey, as x goes towards something, it's asking you, where is f of x going? That's all this is saying. So what this is asking you is, it's saying, where is f of x approaching as x goes towards whatever it is that I happen to have in there. That's what this is asking you. And it's read, the limit of f of x as x approaches. That's how you read this. The limit of f of x as x approaches blank is something. So again, limit is, where is f of x going as x approaches some value. That's all that's going to happen here. Now, what I can put here is, I can put infinity, I can put negative infinity, I can put any vertical asymptote in here, or I can put any hole I want in here. Let me write that down again. So the things that could possibly go in here. These are the things you're going to see show up for the star. You might see an infinity symbol. You might see a negative infinity symbol. You might see one of the vertical asymptote values, or you might see the hole. Now, all of those existed in this problem, correct? Every single one of those existed in this problem. We're going to do each one of those, okay? So let's do this. Okay, the first I'm going to write down, I'm going to do the infinity and the negative infinity one. So I'm going to write the limit of f of x as x approaches negative infinity. Okay, so what do? X approaches negative infinity. Where am I going on the graph? Which direction? Where is x going towards negative infinity? First of all, what axis would it be on? Make axis. Where is the x equal to negative x on the left. Where's negative infinity on the x-axis? Way, way, way out to the left. So what this is really asking you is, hey, as the graph goes further and further and further to the left, what is my y value getting closer and closer and closer to? That's what it's asking you. Yeah, it's getting closer and closer to 0. Why? Because that's the what? Horizontal asymptote. That's the horizontal asymptote. So guess what? If I wrote down the limit of f of x as x approaches positive infinity, now I'm saying as you go further out to the right, what is y getting closer and closer to? 0. Okay, what do you think about those two? Not bad, right? Okay, now the next part we're going to talk about is vertical asymptote. Okay, so the vertical asymptote here, let's just work with this one right here. Okay, so this was at x equals -1. Okay, now if I were to write down the following, the limit of f of x as x approaches -1. Okay, the way I have this written right now, you cannot answer this. And the reason you cannot answer this is because the graph approaches -1 from two different directions. As I come from the left, as x comes from the left towards -1, my graph's going up. But as I approach -1 from the right, my graph is going which direction? Down. So I can't give a for sure answer on this, okay? So somehow I have to tell you which side do I want you to come from, either the left or the right. I have to dictate that to you. The way that is done is to the right of this, you might see something that looks like this, a little plus sign. Or you might see a little minus sign. This is saying I want to approach -1 from the positive side. The positive side would be the what side? The right side. Okay, so if I was doing this, if I'm tracing my graph and I'm getting closer and closer to -1, and I'm coming from the right side, where is the graph going? Where are my y values going? Where are they heading? Where are they heading? Down to what? Negative infinity. What's that? Here, as I go down? No, here's 0. Remember, this is a y value. Where are my y values going as I get closer and closer to -1? This graph is going down, 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 down. Every time I get closer, it goes down further. It's not approaching 0. Okay? Now, if I wrote this, what's the limit of f of x as x approaches -1 from the left-hand side? Now it's different. Now I'm going to go ahead and be looking at this, and I'm going, and I'm approaching from the left-hand side, and where is my y values going? To positive infinity. Okay? Questions on those two? No? All right, so we've taken care of this, this, and this. Now we got to talk about this. Okay, where was the hole at on this problem? I don't remember what we said. At -5. Okay, so -5 is right here. Here's -5. That's where the hole is. Okay, now I'm going to go to the actual Desmos here. And we're going to do this. So here we go. All right, so I'm just going to zoom in on this part of the graph. And if I want, I could trace like this. Now, if I try to get really close, oh, look, see what happens when I get to -5? It says it's what? Undefined. But it looks like if I came back just a little bit, it looks like it's about what? -0.3. And if I go to the other side, it says it's negative 0.3. Now, how do I know if that's really what it is? Is that what it's getting close to? It looks like as I get closer and closer to negative 5, it's getting closer and closer and closer to negative 0.3. All right, here's how we do this. Everyone needs to pay attention. So I'm going to do the problem. I'm going to write down what I'm trying to find right here. I'm trying to find now the limit of f of x as x approaches negative 5. Now, it doesn't matter if it's from the left or the right because they're approaching the exact same location. Okay? Now watch. I'm going to come back up here to my original problem. Okay? What we're going to do is we're going to find this by direct substitution. In other words, I'm going to evaluate this at x equals negative 5. But before I can do that, I have to do one little thing. I'm going to take this and rewrite it as this. X plus 5, x minus 1's on the bottom. The top was 2x plus 1 and x plus 5. Okay, so now what I've done is I've written this in factored form over factored form. We should know that anything over itself does what? Cancels. Guess what I'm going to do? I'm going to remove those common factors and evaluate with what is left. Okay, so watch. Let me go ahead and do this. I'm going to, what did I say I want it to be? Where's the hole at? At x equals? So I put negative 5 here, here, and here. I'm now going to find q of negative 5 with my remaining factors. So what am I going to have up here? 2 times negative 5 plus 1 over negative 5 times negative 5 minus 1. What do I get on the top? Negative 10 plus 1 is negative 9. What do I get on the bottom? Negative 5 times, which is negative, you get positive 30, right? Boom. Simplify this for me. They're both divisible by 3. What do I get? Negative 3 over, isn't that negative 0.3? There's the answer. And it's exact. It's a fraction. Because it's not always going to be a nice, neat number like that. It won't always give it to you on Desmos, in other words. So the only real way of doing it is it's called removing the point of discontinuity. That's what we just did. This hole is called a point of discontinuity because the graph is non-continuous at that point. I have to hop over it. So what we do is we remove the hole by getting rid of those common factors. And once we get rid of the common factors, we can then evaluate at that. That's what we're able to do. Now that's the last part of this lesson. Right there, this idea of limits. Limits at infinity, limits at negative infinity, limits as I approach a vertical asymptote, or limits as I approach a hole. We're going to practice these real fast. Yeah. So the answer to this, where is y going as I get closer and closer to negative 5? It's getting closer and closer to negative 0.3. It never will actually be equal to that. It can't be. But it's going to get really, 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 really close to it. That's what we say it's approaching. Okay? Now, guess what? We are going to use the previous problems that we just did to do some limits. So what you're going to do, you should have these. If I go back, okay, this was the previous one, all right? You're going to graph it. You're going to graph it on Desmos yourself. And I want you to find the following limits for this. Okay, so here we go. I'm just going to write some down. Okay. What is this? G of x. The limit of g of x as x approaches infinity. I want you to find that one. I would like for you to find the limit of g of x as x approaches 6 from the left-hand side. Okay? And then I want you to find the limit of g of x as x approaches the whole, which is at x equals 0. Oh, not x. X approaches 0. Those three. Now, 2 of them you do from the graph. These 2 you do from the graph. This one you really need to do by direct substitution method. Okay? So try those 3. Do this. Let me take this. This. File, save as. Save as. Okay. Here. Class work. Create assignment. Okay, upload. Let's get this open. And 7th period. And post it. Okay. So here we go. All right, so what is the limit of g of x as x goes to the right? As this graph goes further and further to the right, what is the graph approaching? And all you have to put is the number 1 because g of x is y, right? Okay, boom, got it. You good with that one? Okay, second one, the limit of g of x as x approaches 6 from the right-hand side. So in other words, is the graph going up or is it going down? Because if it's going up, it's going towards what? Infinity. If it's going down, it's going towards negative infinity. So which way is it going? Up or down as I approach 6 from the left-hand side? It's going down. So it's approaching what then? Negative infinity. So that's what's going on there, okay? The last one, now I have to do the whole remove. So I'm going to actually look at it. What's going to get canceled out here? If I come back up here and write this down, I'm going to have g of x equals x times x minus 4 times x plus 2 over x times x minus 6 times x plus 1. So what gets canceled out? This. And now I do what? Now I evaluate at g of 0. Oh, wait a second. G of 0 is a what? We're going to plug it in here. Here we go. 0 minus 4 is? Negative 4 times 2 over negative 6 times 1, which is negative 8 over negative 6, which is 8 over 6, which is what? 4 over 3. There it is. There's the exact value it's approaching. See, if you've already done all the factoring up here to find the vertical asymptotes and the holes, it's not a big deal to find that thing. You've already done the factoring up front. So the limit then is not an issue. Okay. Questions on this one? All right, last one for you until I give you your practice sheet. Okay. Whoa, wait, I gotta go back the other way. This is the first one we did in here today. Okay. So let's go ahead and do it. Here we go. So what's the limit of f of x as x approaches 6 from the right-hand side? What is the limit of f of x as x approaches 2? Okay. And I'm not even going to do the end behavior one. That's the easiest one of all. Right? Like the right and left hand side. So let's do these two here. Okay. Whoa.
Mr. Shire, where's Miss Happy?
I fired her. Is that okay?
No, it's not.
It's not okay that I fired her? This period, she is exactly sensitive. 1, 2, 3, 4 classes. She should be in there, okay? This means approaching 6 from the right. Because it's set because this is the plus side of the graph. So you're coming from, if you're going to come from here, you have to go that way. If I put a negative here, I'm telling you to come from the negative side, which means you have to go this direction to get towards the asymptote. Okay? So you're always working your way from the outside in is what you're doing towards the asymptote. From the positive side or the negative side. What? No, I didn't want that. My keyboard, what is going on? I have to delete that. Okay, so let's go ahead and do this. The first one, x equals 6. So I'm going to just turn this one off. So as I'm approaching x equals 6, here it is, from the right-hand side. Okay, where am I at? I'm coming from this direction then. So where is my graph going? It's going which direction? Up. So if it's going up, the y values are going more and more positive, which means they're getting towards positive infinity. So yes, so this one here is going to be positive infinity. Now, this one, this is why I want you to be able to do by direct substitution. The x equals 2, if I turn this off, You don't want to have to try to find where is it hitting one of these parts of the graph. Yeah. Oh, I don't think so. It's supposed to be what? Back, I tried to delete that earlier. What? There we go. Okay. So now here's the x equals 2. We're good. So boom, I could do this undefined. It looks like it's, oh, that's not a very pleasant thing. Negative 1.619. That's okay. So we're going to do this by direct substitution for sure. So let's do it. So we'll write our factors out, cancel off what's left. So this was infinity. So this one here, so we've got x minus 6, x minus 2 on the bottom. The top, x plus 5, x minus 2. So this is f of x right here. Here it is. Cross off the x minus 2s, and now evaluate, find f of 2. So what they're going to be, 2 plus 5 is 7 over 2 minus 6 is negative 4. That's your answer, negative 7/4. Boom. Okay, so that's what it's getting closer to. And it doesn't matter which direction you're coming from. That's what it's approaching, negative 7/4. That's what the test on Thursday is going to be about. It's going to be these two things we talked about yesterday and today. That's it. That's really not that much. Okay? And you're allowed to use Desmos on the test. Do I expect to see the factors on there? Yes, I do. Okay? You have to show me the factoring on there. So, what you're going to get right now, this yellow sheet, is basically a different version of the test. So if you can do this, you're going to do great on the test. Plain and simple. Okay? I want to be able to give you the test first thing, third period on Thursday. Again, why? Because I want to be able to grade them as you're turning them in, so I can put them in and your grade's done before you leave on Thursday. That's what I want to be able to do. Okay? So if you have questions, you need to come in before school or before class on Thursday and quickly take care of them, right? We're going to look at this real fast. So the front is going to look just like the homework from last night. Yeah.
Well, like what we're working on right now, be on the exam.
Will it be on the exam?
Yeah.
Probably, yeah. Yep. Say that again? Yeah, you can. Okay. So, real quick, let's look at this, guys. So the front, as I said, is basically like we did last night, we're supposed to do last night, and we did at the beginning of class. On the back, and we'll look at the back real fast, so you don't get confused. If you look at the top graph is number 4, okay? The function f of x is given at the top right. Below it, you will see there are 3 limits to find. The one on the left says the limit of f of x as x approaches infinity. The one in the middle says the limit of f of x as x approaches negative 3 from the plus side. That plus can be in the top or the bottom. It's the same thing, that little plus. And the last one says the limit of f of x as x approaches the what? You have to find the hole on your own. I'm just making you factor this to find the hole. I didn't give you where the hole is. That's all I'm saying to you. So you find the hole first, there is one, and then find the limit as you approach it. That's exactly how it's going to be written on the test tomorrow as well. That problem is, I know it. On the bottom, I have given you a graph with the asymptotes on it. Okay? Those dotted lines are asymptotes. I have not given you the actual function. On number 5, there are 2 limits. What is the limit as x approaches negative infinity? And what is the limit as x approaches 2 from the right-hand side? That's it. That's exactly what your test is going to look like tomorrow, on Thursday. Okay? Any questions? No? Great. Great, great, great. Onliners, it's posted for you. Turn that off. Turn this off. What's this? Close this. Okay. Done. Done.
Are you supposed to keep those tomorrow?
If I don't post it tonight, I'll post it tomorrow. I'm not sure if I'll get to it today. Yeah, I'll post an answer key probably tomorrow for it.
How do you get that? I wasn't here.
Oh, okay. So if you find this, let me go ahead and go back to my notes because I can show you better.
I didn't do the homework because I didn't know how to do it.
Okay, so
I don't know, it could work. Or is it actually just a
all right, so here was the homework. Okay, so we always start by finding the horizontal asymptote. That's just comparing the domain, the powers, the degree.
It's like the right.
It's the leading coefficient over the leading coefficient if they're the same. If they're the same. Now, but one of the things we said in here was, if you're trying to find, if you're given a this, okay, zeros are always found by finding the zeros of the numerator. Vertical asymptotes are always found by finding the zeros of the denominator. Okay, now and then the horizontal asymptote is all about comparing the degree of the top and the bottom. So this was what we talked about yesterday. Now, what we found out was if you have a value of x that's a 0 and also a vertical asymptote. So an example would be right here on this one. See how there's a 0 of x equals 2 and a vertical asymptote also of x equals 2? What you say is, oh, wait, that can't be. That means really and truly there's a hole at x equals 2. So if you have the same thing show up in zeros and vertical asymptotes, it's neither, it's a hole. So if I come down here, notice again, -3, that's the hole. That's what you do. Now these notes will be posted so you can go back and look at these as examples if you need to.
So how did you get it?
That's always where you set the denominator equal to 0 and solve it.
Yes.
And the zeros are the numerator. So you have to do these two. You do these two first, and they allow you to find the horizontal you do first. That's just has nothing to do with anything other than comparing degrees. You do vertical and zeros, and then those give you the whole, if there's any that exist. And the domain comes from knowing your zeros and your vertical asymptotes.
So the zero is something with the numerator, right?
Correct, because a fraction is 0 when the numerator is 0.
Okay, so all of these are 0. And I did the top one.
Yes, correct. So those go here.
And then if any of them are the same.
And then if you get and then now you have to find the zeros of the denominator. If you get a denominator that has the exact same zero, that's a whole instead.
And then the whole you write as like that as a domain.
The holes, then whatever you have for holes and vertical asymptotes, those are the restrictions on the domain. So what do I have left here? 3, 0, and I'm sorry. Yeah, not zeros. Vertical asymptotes and holes. 0, 1, and 3 are my restrictions. That's why they are the numbers showing up here. Those are the values you cannot use in the function at all. Right?
Is it possible we can exempt this exam or do we have to take it as two periods?
You can exempt it. Yeah, it's a class.
Oh.
You can exempt an exam for a class, not a period. So if you exempt mine, because I have to put down if I'm giving my exam like 3rd or 4th, 5th. So I only give it during a period. So that's why you're allowed to exempt it.
Okay.
See you guys. That makes sense.
Yeah, so like, are you gonna fill out papers on Thursday? Or?
If I get your test graded, I will. If not, you have to come before advisory on Friday and I'll fill them out.
All right.
If I get them done. If I get your test graded. Now, if I don't get them graded during your class period, I could probably grade them during the next period when they're taking it. So you might be able to come back before you leave for the day and get it filled out if you want, but it's got to be either one of those. Okay. I think that's what it is. Yeah. So that's why the latest I can do it is before advisory on Friday.
I remember you says no one knows.
What do you mean?
Like when they're due.
I
Like, they
can
haven't been
explain that.
told, like, a date.
Yeah, it hasn't been real clear this year, like a lot of things, unfortunately. Let's make. I back out of this.
Have a good day, Mr. Snyder.
You too.
I don't know why you put all the time. But it straight up.
Come on. What is wrong with my computer?